area of a surface of revolution, we derive the formula for the surface of revolution s equals 2 pi, the integral from a to b, f of x, the square root of 1 plus f prime of x squared dx, where the radius of revolution is y or f of x, and the arc length differential is ds. For example, confirm that the surface area of a sphere of radius r is 4 pi r squared. The equation of the circle is x squared plus y squared equals r squared, and so y equals plus or minus the square root of r squared minus x squared. The positive piece is the upper curve. Using the arc length formula, f of x is y equals the square root of r squared minus x squared. F prime of x is 1 over 2 the square root of r squared minus x squared times minus 2x using the chain rule. In the arc length formula, we would need to square f prime of x. So to simplify f prime of x, we end up with negative x over the square root of r squared minus x squared. F prime of x squared is therefore x squared over r squared minus x squared. In the area of the surface of revolution, we need to add 1 to the square root of f prime of x. This is 1 plus x squared over r squared minus x squared. Combine the two terms. The common denominator is r squared minus x squared. The numerator is r squared minus x squared plus x squared, which is r squared over r squared minus x squared. S equals the integral from a to b, where a is negative r and b is capital R. The radius of revolution is y equals f of x, but y is the square root of r squared minus x squared. The differential arc length is the square root of 1 plus f prime of x squared, which is the square root of r squared over r squared minus x squared dx. Simplifying this, we have 2 times the integral from 0 to r 2 pi r times dx by symmetry. This is 4 pi r, the integral from 0 to r dx. This is 4 pi r times x evaluated at 0 to r, or simply 4 pi r squared. This is the surface area of a sphere of radius r. Another example, find the surface area of y equals x to the 1/2 minus 1/3 x to the 3/2 about the x-axis for 1 less than or equal to x less than or equal to 3. Y is x to the 1/2 minus 1/3 x to the 3/2. Y prime or f prime of x is therefore 1 over 2 x to the negative 1/2 minus 1 over 3 times 3 over 2 x to the 1/2. Rewriting this as 1 over 2 the square root of x minus the square root of x over 2. F prime of x squared is the square root of this binomial, 1 over 2 root x minus root x over 2. Multiplying this out, we have 1 over 4x minus 2 times 1 over 2 root x times root x over 2 plus x over 4. Simplifying this further, 1 over 4x minus 1/2 plus x over 4. We then add 1 to the square of f prime of x. This is 1 plus 1 over 4x minus 1/2 plus x over 4. 1 minus 1/2 is 1/2. This simplifies to 1 over 4x plus 1/2 plus x over 4. But this looks like the previous trinomial, but this trinomial is the square root of 1 over 2 root x minus root x over 2. Therefore, this trinomial is the square root of 1 over 2 root x plus root x over 2. Using the formula for the area of the surface of revolution, S equals the integral from a to b, where a is 1, b is 3, 2 pi times the radius of revolution is the height of the function x to the 1/2 minus 1/3 x to the 3/2. And the difference or arc length is the square root of 1 plus f prime of x squared, which we found it is 1 over 2 root x plus root x over 2. The square root of the square canceled out. We end up with the integral from 1 to 3, 2 pi, x to the 1/2 minus 1/3 x 3/2 times 1 over 2 root x plus root x over 2 dx. Before we use the fundamental theorem of calculus to evaluate this integral, we will simplify the integrand by multiplying the terms. X to the 1/2 times 2x to the 1/2 is 1/2. X to the 1/2 times x to the 1/2 over 2 is x over 2. 1/3 x to the 3/2 times 1 over 2 x to the 1/2 is 1 over 6 times x. The coefficient 1/3 times 1/2 is 1/6, but the power is 3/2 minus 1/2, which is 2 over 2 or 1. The last terms 1/3 x to the 3/2 times x to the 1/2 over 2. We add the powers 3/2 plus 1/2, which is 4/2. And so it is 1 over 6 x squared. We still need to combine like terms. 1 over 2x minus 1 over 6x is 1 over 3x. This integral is now 2 pi, the integral from 1 to 3, 1/2, plus 1 over 3x minus 1 over 6x squared dx. We can now find the antiderivative of each of the terms. The antiderivative of 1/2 is 1/2 x. The antiderivative of 1 over 3x is 1 over 6x squared. And the antiderivative of 1 over 6x squared is 1 over 18x cubed. We then apply the fundamental theorem of calculus. Plug in 3 into this antiderivative, we have 3/2. Plug in 1, we have 11 over 18. 3/2 minus 11 over 18 is 8 over 9. And so the surface area is 16 pi over 9. It is the exact area.